Are we live already? Are we live? Looks like we're live. Hello everyone and welcome to yet another losing session. How about that? I bet you didn't expect that shit to happen yet again. So let's make a little bit of an announcement. And so this is gonna be a red circle, right? Live on Twitch. And what are we doing on twitch.tv? I'm still streaming on this website. I'm actually quite surprised that I still do that. Okay, so let me give the link, https://twitch.tv/todding, and I'm gonna ping everyone who's interested in being pinged, and there we go, the stream has officially started. Alright, for the past 2 streams we were developing a very interesting programming language that I call Noq, which is not Coq, right? Coq is basically a proof assistant that allows you to, you know, define some theorems and stuff like that and then prove them. And what I found while using Coq is that in the majority of the situations, I personally just want to transform some expressions, right? So I know that Coq is a very complicated system and very serious people, very serious mathematicians are using it for, you know, proving different theorems and developing different theories and stuff like that. I do not invalidate that. I'm just saying that I personally, quite often, just want to transform a bunch of expressions without going through all of these like mathematical formalisms, right? So I don't want to prove anything. I just want to, you know, doodle around. And what I did, I came up with this system which is just a simple expression transformer which is not trying to be Coq, right? It is not trying to replace Coq, it is not trying to be Coq, it is not trying to be like a proof assistant or anything. It's just a simple expression transformer. Right, so I already developed a little bit of that language, so it already has a syntax, it already has a REPL, and it can already interpret the files and stuff like that, so we're gonna go through that a little bit later. And today we're gonna actually try to extend this language and add some, you know, more features and stuff like that. I think it's gonna be fun. It's actually a pretty fun language. So you can find the source code of this language in chat. I'm gonna copy paste it in the chat. And for people who's watching on Twitch, I think I'm gonna put that in the description. Alright, so let me take a look. So we already have a description for the previous episode. I still haven't uploaded a lot of episodes, to be fair. So I already have like a, you know, 2 episodes of Noq that I haven't uploaded, so I'll have to you know, put something in there. So I don't quite remember. So there was a Noq 1, this is Noq 2. Oh yeah, so this is actually 4th episode. That's quite interesting. So it's gonna be description.md and we're gonna put the references in here, right? So this is gonna be source code. Right, so this is the source code of this entire thing that we're developing, and let's take a look at that system, shall we? Hello everyone, how are you guys doing? How are you guys doing? Hello. HTML parser when? I don't know, just use regular expressions. Why do you need an HTML parser if you can just use regular expressions? Like, I don't understand. I think developing HTML parser is kind of a waste of time. Nice hair, nice, thank you. I just lost my hairband, so how is it called? Like a rubber thingy that like makes me, lets me do a ponytail. I just lost that, so that's why my hair looks like that. I really apologize for that. So I didn't mean to look like that today, but I just like lost the thingy-majingy. Alright, so let's actually go into Noq. Right, and let's take a look at this entire thing. So what do we have in here? Let me do clean fdx and maybe even git fetch prune origin. And let's merge origin master. Okay, so this is how many changes I've made off screen, right? So this language already can do things. And let's actually start the REPL, right? So when you start the language, you're greeted with a REPL after like a half of an hour of downloading dependencies and building everything. I'm just joking, by the way. This language doesn't have any dependencies yet. I don't know if I'm gonna add something in the future. I plan to add something for cross-platform terminal handling, so to add some colors, because kids these days like colors in their repos and stuff like that, so I'm probably gonna add that, but we'll see. So in any case, you are greeted with this repo, right? So language has like a core. At the core of the language we have expressions, right? And expression is actually very simple thing. It has a very simple syntax, right? So I even have like a BNF of expressions in here. So essentially expression is either a symbol or a functor. A symbol is just a name of alphanumeric characters, right? It's a sequence of alphanumeric characters, right? And a functor is symbol, right, then open paren, then a list of expressions. As you can see, it's a recursive thing, right? So it's a self-recursive definition, separated by commas and enclosed by closing paren. So this is an expression, right? You have symbols and you have functors. So it's kind of close to lambda calculus, I think. In lambda calculus you have, well, I mean, it's actually a little bit simpler than lambda calculus, right? Because we don't have lambda functions. So in lambda calculus, you have variables and functions and applications. So in this particular case, we only have like variables and applications, but we don't have lambda functions. Maybe in the future I'm going to introduce them. I haven't decided yet. So yeah, in any case, so we have a notion of expressions, right? But expression is just like a thing that you can put in a language. The language revolves around two concepts. The first concept is rule, and the second concept is a process of shaping. Rule is essentially an equation, right? So you define that a particular pattern is equal to another pattern, and the left hand side is called head and the right hand side is called body. So the head is matched against your expression and then replaced with the body, substituting the corresponding matched variables, right? So this is a rule. So, and you can define several rules. You can define, like, you can use the rule keyword, then you can define the name of the rule, and then you can define the head equal body, right? So, and you can have a list of that rules. They don't do anything yet, you just define them, right? Then you start the process of shaping. And shaping is essentially like transforming the expressions, applying the rules, right? You start the process by using keyword shape and providing the expression. After that, you essentially do apply and the name of the rule, right? And you can actually have like several of rule applications, and all of them are going to transform the expression. And at some point you can say, okay, I'm done, and then you'll get a final expression. So it's not going to do any particularly interesting side effects. It will just, you know, print you the final expressions after a sequence of rule applications, right? So, and as I already said, this language is designed to do mathematical doodles, right? So essentially you just want to see how you can transform one expression into another one by applying sequence of rules, right? You can do that on a paper. Mathematicians quite often do that on a paper, right? So they have some theorems, some axioms, and applying them, they just transform the expression until they get somewhere and they satisfied with that, right? In our case, we're just like trying to automate that with a computer, right? So you don't have to like do that manually. You just define a rule and you can apply that rule. You can apply them in different combinations and see where you can go. So what's interesting is that in majority of the situations, Noq is kind of doing that, right? But on top of that, it has some fancy strategies that try to brute force the expression transformation by applying different like rules and trying to find a particular like path that proves your theorem or something. I'm not trying to be fancy like that, but maybe I will be, we'll see. So right now this thing is intended to be like a very simple mathematical thinking, right? Okay, so and let's actually take a look at how this entire thing works, right? So let's define a rule, right? So let's define a rule that is provided here in the README. So this is going to be a swap rule, right? And swap is essentially a functor. You know what? I have an idea. What if I wrap it with RL wrap so I have a read line interface, right? So if you never heard about RL wrap, it's a very useful utility. So if your command line program does not support read line interface, you can just use this thing and it will automatically support it. So it's actually very, very useful. I'm going to put that in the description as well. Right, so rel rup. So maybe at some point I will just like add a rel like read line as a third-party dependency. I don't know if Rust has something like that, but whatever. So in any case, I'm going to define a rule swap, and here I'm going to have a functor swap. Inside of a functor swap, I'm going to have a pair, and inside of a pair, I'm going to say that I'm going to have a couple of variables, like A and B. And that thing should be transformed into a pair BA. And there we go, I defined a rule that matches this expression, and essentially just transforms it into that. Okay, let's try to shape something. Let's shape swap pair f of x and g of y. There we go. We started shaping, right? And as you can see here, this is the current expression. And then you can say, okay, let's apply a rule swap. And as you can see, it worked. So it power matched this thing onto this thing, and it recognized that A is equal to f of x and B is equal to g of y, right? And then it replaced it with the body, replacing the corresponding variables, and this is what we got. So this is essentially what we got. And I don't really have any other rules. So yeah, I can just say that I'm done, and there we go. So this was my final shaping expression. And you can do even some fancy stuff. For example, you can do arithmetic operations on piano numbers. Do you guys know what is a piano numbers? Right, so basically it's basically axioms on a very basic arithmetic, right? Arithmetic of natural numbers and addition, subtraction, multiplication, and stuff like that. And you can try to represent piano numbers in this system with functors, right? So you can use 0 as the number 0, right? Since we don't have numbers, we just consider 0 as a symbol, right? And then to add 1, you can wrap this thing with a functor s, right? If you have a piano number and you wrap it with a functor s, it will increment it by 1. So this is a number 1. S of 0 is going to be number 2. So basically how many layers of s you have, this is the number, right? So you have 3 s's and this is basically 3, right? So how do you add two piano numbers, right? So you want to define a rule, something like add, right? And add adds two numbers. But essentially, you want to pattern match the first number of as s of a, and you want to be sort of like recursive, right? So you can say that if you add s of a and b, you basically end up with s of add a and b, right? So this is a recursive rule. So now, if you try to shape something like, let's say, add s of 0, so this is basically 3, and then let's say maybe 4 s of 0. So basically trying to add 3 and 4, right? And first thing I'm going to do, I'm going to try to apply rule add. And there we go. So as you can see, the first layer of s was peeled off, and now we have add inside of it. So basically we applied this rule. We can keep applying this rule, right, until we get to an interesting point where we're trying to add 0. But if I try to apply this rule yet again, it doesn't really match, so our recursion doesn't really go anywhere. So you need to define like a base rule where you add 0 to essentially any number, and when you add 0 to any number, you get that specific number anyway. So after that I can apply add 0, and there you go, I ended up with a sum of 3 and 4, right? 1 2 3 4 5 6 7, and this is a piano number 7. Right, so essentially you can even do like a very simple arithmetic in this system. I really recommend to check out piano axioms and stuff like that. It is very, very interesting, and you can do this stuff in here. So what I'm planning to also implement is some sort of like a rule application strategies. For example, here you may want to apply the same rule until it applies, right? So, and that way you can even have some sort of like maybe even Turing complete systems, right? So no, we can even define some sort of like a list of values like pair 0, pair 1, pair 0, and so on and so forth, and like have a list of you know, bits. And then we can define rules that calculate rule 110 over that list, proving this entire system Turing complete. I think we can do that. It's not quite there yet, but I feel like we can get to that point where we can even have the system to be Turing complete and have Turing complete, you know, cellular automatons. I don't know how to pronounce that word yet. So I've been developing these kind of things for quite some time. I still don't know how to pronounce the word automaton. It's a singular one, automata, right? So because I know automaton is a singular and the plural one is automata or something. I can't remember. I'm sorry, I don't speak English. So I don't know automaton. Can I say that automatons? Why do you have to have a separate word for plural, right? Automata. Because it's Latin. Yeah, I see. Anyway, so this is the system. Yeah. And of course, you can actually put all of these commands into a file, right? And in fact, I did exactly that. Let me see. So Noq, and I have a couple of examples, and the piano number example is in here, right? So you can do it like that. But of course, there is no highlighting. But I implemented the simple editor support for Noq, right? So here it is. It is in the editor folder. Let me actually quickly install this entire thing. So I'm going to put it in a local thingy-majingy, right? In a local thingy-majingy, and then I'm going to go into Emacs, right? And let me find ports. Yeah. So this one is going to be Noq mod. Okay. So if I take a look at the example, so this is how the piano numbers example look like, right? You can essentially just put these things in a file, and then you can simply execute that file, right? You can do Noq. In our case, we're using Cargo because it's written in Rust, and then we can do add. And there you go. So it basically traces the execution, the transformation of the expression, right? So there you go. So you can have REPL, or you can put all of the commands from REPL into a file, and you will just execute that, right? So we cannot really load rules from other files yet, so there is no modular system or whatnot. But in the future, we're going to have something like that. So that's the current state of this very simple language. It's not a proper programming language. It's a very specialized language for transforming, you know, algebraic symbolic expressions, if that makes any sense. So, yeah, does that make any sense? By the way, speaking of sense, does anyone have any questions regarding the thing? So, yeah. Basically, what I tried to do, I tried to extract the essence of Coq that I really care about. I know that it's not the actual essence of Coq. Coq is completely about different thing. But every time I work with Coq, this is what I want from it. This is what I want to be able to do, right? Without any formalism, without any bureaucracy. I just I have an expression and I have a bunch of substitution rules, and I just want to get that expression to a particular state. So yeah, and Coq is really finicky in that sense, and it also uses this cryptic mathematical language, and it's really difficult to Google how to do things in it, so it's easier for me to just implement my expression substitution system. Will it be possible to write charge numbers in Noq? To be fair, charge numbers are basically piano numbers, but with lambda calculus. They actually are, believe it or not. So essentially, it's just amount of lambda functions around, I think, ID function, right? So you have ID function, how many? Oh, no. Yeah, it's basically piano numbers, because you have a function that takes two arguments, another function and x, and the number is basically how many times you apply that function over x, right? So yeah, it's basically the same thing. Are things like matrices possible then? I think matrices are too high a level of math. We're lower level, right? We're more on the level of computational theory rather. We're closer to set theory, right? So the bottom line, the bottom of math is set theory. Right, and then we build up to numbers, and from numbers we build up to matrices. Right, so the Noq is somewhere between basic arithmetics and set theory, like somewhere in between. So matrices is too high level for Noq right now, but maybe in the future we're gonna have something like that. Didn't Russia switch to intranet? So far they just banned Instagram and Facebook, which is kind of strange. Right. They tried to ban all of the services of Meta, and they did that, but they didn't ban WhatsApp for whatever reason. Right. It's kind of strange. A church number is just a P&O number, but with the successive function extracted as an arbitrary function parameter. Yeah, basically, I guess. Maybe they use WhatsApp in government channels. Probably. That's probably true. I also know for a fact that government also uses Telegram for for different stuff. So, yeah. They are using the very thing they were trying to ban at some point. It's just a fucking shit show. Anyway, so let's start developing the thing. So while I was developing this language, I actually discovered a very interesting source of confusion. Right, let me take a look at that thing. So I even created an issue. Can you believe that? I created an issue for a source of confusion. Replacing name of a functor turns into a symbol. Right. So imagine that we have, we're trying to shape f of ABC, right? So this is basically the thing. And then we apply the rule f equal g. And I would actually expect this entire thing turned into g of A, B, and C. But instead, it turns into just g. We can even verify that. Let's actually go ahead and verify that. Right, so I'm going to try to shape f of A, B, and C. Right, there we go. So, and I'm trying to apply... by the way, you don't have to define rules before applying them. You can have anonymous rules, right? And to apply anonymous rule, you just apply a rule, and you define a rule without a name. Right, you just say, okay, f equal g. So this is going to be a temporary anonymous rule, and you won't be able to reuse it anymore unless you define it somewhere with the name. But you don't have to predefine them. You can just like apply a sequence of rules, like anonymous rules, and that will work. Right. So there we go. If you try to apply that, it turns this entire thing into G, which is like kind of weird, right? So it doesn't even preserve this thing to be a functor. It turned it straight into a symbol. Right, so we need to understand what's up with that. In fact, it turned out that this is by design, because f is recognized as a variable that matches the whole expression, right? So essentially in this rule, f was a variable and it matched the whole expression in here, so it replaced the whole expression with g. So, I mean, it's kind of by design, right? So the problem here is that symbols and bindable variables are the same thing, right? Symbols and bindable variables are the same thing, and this is kind of a problem, right? You can keep that in mind and just live with that, or we can try to distinguish something that is bindable and something that is not bindable, like symbols and whatnot. And this is something that I proposed in here, right? We can just resolve this confusion by introducing a special kind of expression called variable and use it for binding the sub-expressions instead of symbols and match the symbols literally. By matching the symbols literally, I mean if I have an expression A right, and I try to replace it with B equals C, it is not gonna match because B is not A, right? To replace it with C, I'll have to have a rule A equals C, right? So right now we do not match them literally, and yeah, it's not gonna work. The variables can be denoted by capitalizing first character of the name, similar to how Prolog does it. So if you ever programmed in Prolog, you know what I'm talking about, right? So essentially X is just an atom or a symbol, but capital X is a variable, and this is going to be the bindable variable, the variable that we match in the pattern matching. So does that make any sense? So SA7 Mouse, thank you so much for tier 1 subscription. Thank you, and welcome back to our epic Noq Club. About that. Applying rule F equal G to FG should either give G a B or just leave F a B C. Probably, but I think it would be kind of cool to introduce like a separate kind of expression with the variable that binds thing, and the user would make a conscious decision on what to bind, what sub-expressions to bind, and what sub-expressions to treat literally, if you know what I mean. I think it will be better. But we don't know actually, so what I want to do, I want to introduce that and see how it will work, or will it work at all. So I'm gonna play with that idea, and if it's not gonna work, if I'll discover some like downside, I will probably change it to something else. So, alrighty. So let's go ahead and do that. So this entire thing is implemented in Rust. So I hope you like Rust, because I hate it. So here is the expression definition, right? So we have two kinds of expressions, right? Symbols and functors. Symbol is just a string, and functor is a string plus a vector of expressions, right? So, and the thing I want to introduce in here, I probably want to introduce a variable. Right, there we go. So now we have a variable, and hopefully by introducing a new enumeration in here, it will break in all sorts of places, letting me know where I have to make the changes, right? So now let me try to just, you know, build the entire thing and see where it's gonna fail. You know, as usual, the compiler assisted refactoring. You just change something and you go through the compilation errors and change things around. Okay, so here we have the, you know, display interface. I'm gonna call traits interface, right? Display interface for expressions, right? It's the interface that comes in place when you try to print a certain expression, right? So something like that, right? And here you have an expression. So what it's supposed to do is just supposed to format it properly. So I don't think the variables are going to be that much different from the symbols. So maybe, can I just do something like this, right? Or expression equal variable, the same name. I wonder if it is possible to do something like that in Rust. It does make sense. Okay, so apparently you can do stuff. Okay. So here is the substitution. Here is the substitution. Substitution. Can't wait for the VOD on YouTube. I haven't uploaded VODs to YouTube for quite some time, but hopefully after this episode I'm gonna start uploading all of the 4 episodes of Noq, because I already have like, this is the 4th one, I'm pretty sure. Right, so it is what it is. I didn't have much time to do that. Unfortunately, because of, you know, stuff that is going on in the world. Hello, Robin here, 95. I'm fine. Everything's fine. Don't worry about me. More or less. More or less. So I'm not the one who should be worried about right now. Any plans to come back to port? Of course, I need to finish that thing. Okay, so here is the substitute bindings, right? And essentially, in here, bindings are name to an expression, right? So a certain name to a particular expression. And I suppose here we match symbols, right? We specifically match symbols. But I think now, since we introduced variables, we have to treat symbols literally, right? So that's the thing we have to do. Oh, by the way, I just realized a very interesting thing. Quite often, I want to replace also the name of the functor, right? So I have an example where I would just do something like this, where I, you know, accept a functor name. Right, and in here I use that name and like just append a bunch of things in here. Right, so that way I want this expression to be replaced to foo123. So that means we should be able to accept variables and set variables as functor names, which is rather interesting if you think about that. Right, so which is rather interesting. So let me take a look at the definition one more time. So right now, the functor name is a string, right? But it should be either symbol or a variable. One thing we can do, we can make it an expression, so it can be either symbol or a variable. But another side effect of that is that now the functor, the name of the functor, can be also another functor, which is rather interesting. So yeah, imagine a functor ABC, and the functor name itself can be another functor, right? So, and essentially what I do in here, maybe that is fine. Maybe we can define a rule, right? Maybe we can define a rule that replaces this pattern to a symbol name, turning that into some function name. That is very interesting, actually, which effectively turns this entire thing, into S expressions, right? But instead of first argument, yeah, this is basically S expressions to some sense, but it's more of M expressions. That is very fascinating, huh? Foydi, thank you so much for 3 months of Twitch Prime subscription. Thank you, and welcome to our epic S expressions club. This is rather interesting. So I think I just rediscovered M expressions of some sort. Yay. So if I take a look at M expressions, right, expressions. So, and I know that M expressions were redesigned as expressions where like the functor name was put behind, you know, behind parentheses, behind brackets. But interestingly enough that, I think they didn't take into account some other stuff. So here is the function application, function definition. But yeah, I don't think they even looked into that problem at all. But anyway, so I think I'm gonna just like make it an expression, and I don't think it's gonna compile. You know why? Because that makes this entire data type recursive, and it's gonna have infinite size. Right, so basically fun includes expression, which includes fun, which includes expression, and basically you have infinite data type, right? So it's not going to compile at all. I think the Rust is going to even tell you, has an infinite size. So one of the things we'll have to do, we'll have to put expression behind the pointer, right? So, and to put it properly behind the pointer, we can use a reference, but if we start like storing references within the data structures, that means we should start thinking in terms of like lifetimes, right? So you have to provide these kind of lifetimes, and you have to keep track of lifetimes. So it's a pain in the ass, probably intentionally, right? It's probably intentionally a pain in the ass to discourage you to do all of that. So usually what you do, you just like wrap it in a box, right? And box, as far as I know, is just like a unique pointer to something in heap, right? So, and that way you just have like a single pointer to something in heap, and it has a single ownership, I think, if I remember correctly. Do we have any Rust developers in chat? Is box basically unique pointer, unique PTR? I think it is a unique PTR, right? Basically. If I recall correctly, Lisp actually allows list as function names. I don't need to recall correctly, I know that for a fact. Well, I mean, depends on the Lisp actually. Common Lisp doesn't really like that very much. Scheme actually encourages shit like that. Scheme actively encourages that. Alright, so let's take a look at how it's going to go. I think it's going to be interesting. I think it is in fact going to be interesting. So let me see. So it's probably going to be a huge pain in the ass to parse, right? So if we're going to have like a functors with names instead of functions. So I have no idea how we're going to parse that, but that's going to be interesting. So anyway, here we have a parsing, right? So here we have a name. We're parsing the functor, right? So we encountered a name, and for now I'm gonna just keep the name a symbol, right? So the name is going to be a symbol, but it is probably not going to work, right? Because it has to be an expression, and the Rust is gonna tell me, so I have to do box new. Is there any shortcut for box new? Right, does anyone know if there's any shortcuts? I'm pretty sure I can do something like rust up doc. Rust up doc. And just take a look at box new, and I hope the documentation is gonna tell me that there is a shortcut. Something like keyword box or something. Box new. Let me see, I only wish my laptop was a little bit faster, and I was genuinely planning to buy a new laptop. But now, after the Iron Curtain has fallen, that's the laptop I'm stuck with. So, it's gonna be fun. But, I mean, that's fine. Nobody's bombing me, after all. So, that should be fine. Yeah. And it's kind of fun. Like I already said that, this is like a 10 years old laptop. And that's basically my last laptop, right, that I'm gonna have in this country. So, yeah. Okay, so they don't really suggest anything, so one of the things we can do is just like take a look at the SRC, right? Are there any Russian-made computers? Okay, so there is a keyword box. I'm not sure if we can use that, but... I wonder if we can use that. It's actually a very interesting question. Can I just like do something like box? Maybe I'm not supposed to do that. Right, maybe I'm not supposed to do it. Syntax is experimental, you can call box new instead. Oh, it's experimental. It's a nightly. Yeah, of course. It's a nightly. I never said about it where they're studying. I do live in Russia. In fact, I'm in the middle of Siberian forest. I wasn't just sent to Siberia as a descendant. I was born in Siberia. Believe it or not. I was born in Siberia and I lived here for my entire life. Okay. Anyways. Expected function found enumeration variant. I think it has to be something like expression symbol. Have you tried being born somewhere else? Yeah, so I ran out of, slots for other places. Okay, so in here is gonna be box new expression symbol. Right, there we go. Have you considered moving? I have considered moving, but it's kind of too late for me to move. So you can Google up, like look up where Novosibirsk is located, right? So if you ever wondered where am I located, I'm located in Novosibirsk. Just like go to Google Maps and see where it is. The 3 closest countries to me right now are Kazakhstan, China, and Mongolia. So which one should I go to? I think I should go straight to China. So yeah. All right. Kazakhstan. I was thinking about moving to Kazakhstan, but another thing, so right now a lot of Russians are moving to neighboring country, creating shit ton of problems for locals and stuff like that, and I don't really want to like contribute to this entire chaos right now, so I'm kind of planning to wait a little bit, but maybe if I wait a little bit it's gonna be too late. Who fucking knows? So I don't know. What I'm thinking is that like I don't really have like high of a standards of living, so if I have at least something to eat and like a very simple laptop, I'm gonna be fine, I guess. So until the times become better, so yeah, I don't know. Serious question, how much influence has Russian politics have on a city that is far away from Moscow? It has enormous amount of influence. You won't believe how Putin keeps everything in control, like the entire country. So yeah, I don't know how he manages to do that, but he manages to do that somehow. All right, so we have a function. Here is another thing. This enumeration variant takes 2 arguments, but only 1 was provided. Probably because I wanted to put this thing here. Okay, so let's go through another places. So here is the substitution. When we're matching function, right? When we're matching function. This one is rather interesting. I think I basically have to do a recursive substitution. Yeah. Oh, and here is the thing. So since Functor, this thing in the Functor is not just a name anymore, I think it has to be called a head. Right, so there's a head of the Functor and a body of the Functor, kind of similar to how we have rules. So yeah, so this is going to be head. Maybe this is going to be arguments, whatever. So here we're going to have a new head. Whatever that's supposed to mean. I don't know what that's supposed to mean, but anyway. Right, so here we're trying to substitute the old head with the current bindings, right? So here's the current bindings, and I suppose this thing, I'm gonna just like keep it as it is. And since we can just have anything as the head of the functor, like this to do, which says like report an expected symbol in the place of a functor name, like is not needed anymore. I can just like have it like that. And here we have new arguments, and we just append new arguments in here. And this is actually, this becomes much simpler, I would say. I think it becomes much simpler. So if I try to compile this thing, probably couldn't do Twitch in China. I'm pretty sure China has like a local streaming service. Do we have anyone from China? Probably not, I don't know. But maybe people who lived in China but then moved to like US or Europe. So do we have anyone from China? Like do you have like a Bilibili? Probably, I don't know. I know almost nothing about like internal Chinese services. What I heard that like a lot of Chinese websites are kind of exposed to the global internet, right? So it's like the Western websites are blocked, but the Chinese websites are available and also available from the outside. And if there's some information, like undesirable information coming from the West into their website, they have control over that website and they can censor it. But through this website, still you can like sort of communicate with the global internet or something like that. I think this is how they work, but I'm not for sure. No, not sure. Come to India, it is growing in technology. It's actually not a bad idea. I'll think about that. Right. My Chinese friend just confirmed no Twitch in China. I see. Interesting. Alrighty, so here we are doing that, and what are the other things we have in here? So expected box. Oh, okay, so I have to wrap that in box as well. Okay, so now here is the symbol, and I suppose what I need to do, symbols are not gonna get substituted. That's for sure. So what I have to return in here is probably that. Though I can just like replace it like this. So if we have a variable, right, we're trying to find a variable in bindings. If we found it in bindings, we just substitute it. But if we're referring to a free variable, that is not in bindings, what should we do? That's a good question. Should we just leave it as it is? Right, so essentially if you have a rule, rule f of x, but you replace it with y, you replace it with variable that does not exist. So what should you do? Should you say that trying to use undefined variable, or should we just let it be? Should we allow so-called free variables that are not bound to anything? Maybe they can be bound to something else. What do you guys think? That's something like Indian food. I never actually had the proper Indian food, though I keep eating basmati rice quite often. Does that count as an Indian food? I just like eat plain basmati rice. I don't know. I mean, Indian food is actually quite complex thing, right? So just eating basmati rice probably doesn't count as Indian food, but I never had a proper Indian food, I'm sorry. Sort of, I see. Basmati rice is actually fucking amazing, I love it. It's just so fragrant. And as far as I know, basmati like literally means fragrant in Hindi, I think. I don't know. Pilau rice, I see. Yeah, it is incredible actually. Hello, Umbrella Marilla. Hello, hello. Okay, so why should we allow free variables? That is a very cool, good question. Why should we allow free variables? I have an interesting idea. I have a very cool idea. We do not support that right now, but in the future we're gonna support that. What if we allow defining rules through shaping? So you see, in the language we have rules which define substitution of one pattern with another one, and we have shaping is the process of applying rules. But what's interesting about shaping is that in shaping you have input expression, right? So you have input expression, then a sequence of applications, and at the end you kind of have an output expression. You see? Right after a sequence of applications, you have an output expression. What if we allow taking this shaping process and saying, okay, this is a new rule now. Right, so essentially it's a rule where a head is going to be an input expression and the body is going to be the output expression of the shaping. And if you have any free variables in here, right, any free variables, these are going to be the variables that are going to be used in the final rule. You see what I mean? So you do allow free variables which can then be reused if you use shaping as the rule. Holy fucking shit, this is so cool. You see what I mean? Holy fuck, I love this idea actually. This is so cool. The fuck? And since we have anonymous rules, right, so you may probably also have a syntax where you apply the rule that is defined through a shaping. So you have a shaping and then you apply the rule that is also defined through another shaping. So using shaping as a way to chain rules, kinda. So shaping becomes like a rule composition. And for that, you kind of need free variables, right? You need the free variables because the free variables becomes the variables of the rule, of the final rule, that can be bound by applying that rule in a different shaping. You see what I mean? That's actually super cool. What is shaping? Shaping is a process of transforming expression by applying a sequence of rules. And rule is basically an equation where you have a pattern that is substituted with another pattern, right? So you can read more about this thing in the source code of the language, right? So in the README, there is like a brief explanation of what is shaping and what is rules and stuff like that. You can check it out in here. So like to do command, right? And for people who's watching on YouTube, it's going to be available in the description. Okay, so that's actually very cool. So because of that, so this is going to be the justification for allowing free variables, right? So that means I'm going to keep it as it is. So in case of symbols, right? So if you encounter the symbol, we treat symbols literally. So I'm going to just like return that expression. I'm going to actually clone that. So there we go. So this is entire implementation of substitution. So I can continue, you know, compiling. Alrighty, so what do we have in here? And here we are applying the rules. Okay, so this is a rule application. So if you encounter a symbol, okay. Okay. So we pattern match this thing, and we got this thing, and we just apply it. Otherwise, if we encounter a variable, right? If we encounter a variable, what do we do in here? So it didn't match, but we encountered variable in here, which is rather strange. Because if this thing was a variable, right, this expression straight up was a variable, I guess for now I can just like leave it as it is. I think just like if it's a variable or symbol, just leave it as it is. Though for the name, we'll also have to do something. So yeah. This is going to be new name, new head, self-apply all. So this becomes head. This becomes head, like this. This becomes new head. New head. So let me see. Oh, by the way, I recently actually found that Humble Bundle is over, unfortunately, so we'll have to remove it at some point. I was hoping that they're gonna run it forever, right? But it was actually until March 25th, so it was until March 25th. But it's actually it was actually a pretty cool bundle, I think. You could get, so how many games? You could get shit ton of games actually. It's actually pretty cool. Unfortunately, I didn't have an opportunity to buy one because by the point they launched it, my PayPal was blocked already. So it was such a shame. Like I was actually thinking to buy that Humble Bundle, but like right after PayPal was blocked, it's just like they launched it. Damn it. Your income stream is affected by current events. Of course, I don't have an income anymore. So yeah, of course it's affected. Like I don't have it. I'm just like literally doing that for free, for fun. And luckily it is fun actually, so I don't mind doing that for fun. I never find out about these bundles until after the end, yeah. You play games, what do you usually play? Right now I'm mainly playing a thing called T-Worlds. T-Worlds, right? Have you ever heard about this game? It's a very old game, right? So since 2007, I think I started to play it when it was actually released. Yeah, I was 17 years old and I still playing it to this day. I actually got pretty good at it, but unfortunately my ping on active service is shit, so I don't know. And speaking of Steam games, I kind of stopped playing Celeste. I was playing Celeste quite actively, but then I stopped at some point. I don't know. T-Worlds. It is a great game. It is absolutely a great game, and it's so underrated. Like, I don't know, it's so great and so fun, and it's just like so dynamic. And you know what's interesting is that it's not only dynamic, but at the same time it is extremely strategic. You may, by playing this game, you may assume that this game is about reaction, but in fact, at some point of skill, reaction doesn't matter anymore, and it turns into tactical game. It becomes some sort of like a real-time chess. Right, it's all about trying to predict the opponent moves and stuff like that. And to the point that even if somebody is using like aimbots, if their strategic game is shit, even aimbots are not gonna help them. Right, because what you're trying to do, you're trying to predict their next move, and reaction at that point doesn't really matter anymore. You know what I mean? So if you ever played like T-Worlds like long enough, you know what I'm talking about. Do you do Didin? No, I never actually got into Didinet, unfortunately. I'm playing vanilla one. So it is about skill and reaction at first, but after you got your skill and reaction to some point, it becomes like irrelevant. Or what becomes important is the strategy, more of a like tactic, right? Strategy is more important for like CTF, like to see the whole picture when you're playing with the team. Anyway, I'm sorry that I go on such a tangent, so yeah. We need to continue developing these things, so I need to wrap it into like this. Okay, so we have a little bit of a dead code, and this is because we never constructed var. And this is actually quite great. So now we need a situation when we construct a var. And when do we construct a var? Essentially, every time we're about to construct a symbol, we need to check if it starts with a capital letter. And if it starts with a capital letter, we should turn it into a variable instead. Let me see. I wonder, does character have something like is upper or is capital or something like that? Is upper. Is upper. So there is such thing as uppercase, which is cool. All right. So let me see. So that means we have to do that somewhere in the expression parser, right? So here is expression parser, and we're about to create a symbol here, right? You see, we're about to create a symbol, but we need to check if name text. Can I just get 0, right? And say if it is, oh boy. This is rather interesting, right? So it might not be available, but it should be available. Does option have a filter? I'm almost certain that option has a filter. It does have a filter. Okay, so somebody who knows functional programming was designing the standard library. Right. So here's the thing. Option is a list with a single element. Think about that. Think about that. Option is just a list with a single element. Hence, everything that is applied to a list can be applied to an option, right? You can map it, you can filter it, right? So by filtering, you either remove that single element or like leave it there. So that's why you have a filter. Zockenheimer, thank you. Thank you so much for 40 months of tier 1 subscription. Thank you, thank you, thank you. And welcome back to our Epic Rust Club. So yeah, it's a 0 or 1 element, right? So that's why you have these like a very list-like operations. You can even insert shit into it. Look at that. Right, so if you had like an empty thing, you can probably insert a new element. I wonder what's going to happen if you try to insert into a full one. Inserts value into an option and returns the mutable reference to it. Already contains a value. The old value is dropped. So by inserting, you sort of replacing it there. So yes. And one of the things I can just do, I can just get 0 and I can filter this thing like so. X is uppercase, right? And then I can do if, right, if let sum, that means I need to construct a variable, otherwise I need to construct a symbol. Or I can actually put that condition inside of this entire thing somehow. Let me think about that. So this is gonna be something like this. So it's either variable or that. Right, so this one could be just a variable. And this one could be just a symbol. Like so. And here is a single condition that you can put inside of... I mean, why not? Who said I can't do that? I wonder if I can just like... yeah, there we go. That's very dank. Look at that dank code. It's the dankest code in the West. Yeah. Well, though, it's kind of... You can just do stuff much simpler, right? Is sum. So that's another way you can do that, right? If sum is going to be variable, otherwise it's going to be symbol. And then we wrap it into the box and we construct a functor out of that. I wonder if maybe something like this would be a little bit better, like it looks a bit better, you know, right? Okay. So string indices, use size. Though, can I just take first instead? Can I just take first? Method first is not available in string. Okay. I'm struggling to get like a first character. So you can do that on the slice, I suppose. Characters first. God damn it. Okay. Characters first. To know method first. Oh, probably next. Right. So characters next. There we go. Finally. Yesu. 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 Okay, that's cool, but that's not enough, because we have to repeat the same shit for this thing, right? So, and what's the easiest way to repeat a thing? You just copy-paste it, right? So, as I always say, the most reusable code is the one that you can just copy-paste. That's the most reusable code out there. Trust me. I know what I'm talking about. I'm a professional software developer with more than 15 years of software development, right? And this is a wisdom I can give you. This is my wisdom for you. The most reusable code is the one that you can copy-paste. All right, so this, like, you literally reusing the code. By copy-pasting it, you literally reusing it. How much more reusable can you get? I don't know. That's the most reusable thing. Just copy-paste. Okay, So now we should try to just do that thing. I don't know. Let me maybe experiment with this with the parser, right? So we're gonna have something like this: fn main. Right, so we're gonna have some sort of a source, right? So here is the source, and here we're gonna have swap pair AB. So here is the source, and then I want to create Alexa, right? I'm gonna create Alexa from an iterator. So this is a source character, and then I can iterate through the tokens. Token in Alexa, and then I'm gonna just print this entire thing like so. This is the token. There we go, and let me just try to... I actually wanted to run that, not just build. Could you please run it? Thank you very much. So what do we have in here? Token cannot be formatted with the default formatter. You what? Meat? Oh, because it has to be actually the debug formatter. Sure. Okay, let's take a look at the tokenization of this thing. So here is the tokenization. We have a symbol, swap, then open parent, symbol, comma, blah, 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 and there we go. So also and is a special token as well, right? So after that, we can try to create an expression, right? So let me see. I might as well just try to print the expression in the debug form, right? So expression pass, and we're gonna pass the mutable Alexa. Though the Alexa has to be pickable, so let me turn it into pickable one. So because the without pickable, it cannot do stuff. All right, so let's take a look at the parsed expression. So it should recognize all of these things as symbols, right? So as you can see, we have a pair, symbol, and also, okay, so that's cool. And the next thing I want to do, what if I turn them into variables, right? So we're going to use the capitalized thing. So will it recognize them as variables? No, we didn't. That's very cool. I'm super happy about that. It did not recognize them as variables. I have no idea why. I think I'm an idiot. How did that happen? Is that because I copy-pasted the code? That's the karma, right? So I copy-pasted the code and it didn't work. So don't copy-paste. So if it's an uppercase, text, characters, uppercase. So uppercase. Honestly, I don't know. So we can try to take this thing and see if it's going to work or not. Where is the main? Right, so let's just put this thing in here. So this is A, right? This is A. And we can try to print this stuff. Though I don't need is sum, right? So let me put this stuff in here. Okay, so it is none, right? So that makes sense. What if I put A in here? It should be sum A. Sum A, okay? I don't see any problems in here. But for some reason in here, it still didn't really work properly, right? You see, so A and B are supposed to be variables, but they are not variables, no matter what I do. Right, you see, they are symbols, they are recognized as symbols. So, fn parse. So here we parse in the expression. And we are about to create... Ah, I see. I only did this entire thing for the functor names, but not for the functor arguments. I need to copy-paste this shit more. Okay, so this is already third time I'm copy-pasting this stuff, right? So look at that. And you know what they say? I think 3 times is a good indicator of the fact that you should factor that out to a separate function. Have you guys heard about that? Right, so like 3 times. If you're repeating the same code 3 times, it's a good time to actually factor that out. So it's probably something that we're gonna do. Okay, so let me see. Let me just confirm that this thing works, and of course something went wrong. So this one is an expression expected. Oh, it has to be okay. Okay, let's actually like wrap it like that. Has to be okay. And there we go. So these things are symbols, and these things are variables, right? So that's exactly what we had in here. Okay, so let me think how we're gonna approach all of that. Though this one is rather interesting, right? Because how should I call that? Var or sim from name, where name is str, right? And this should return an expression. So that's what we're gonna have in here. And then I can just like take this entire thing and put it in here, right? And here is an interesting thing. If name is empty, this is not gonna crash, right? This is not gonna crash. It's gonna be silently recognized as a symbol. So I think we need to replace next this thing. Actually, we should unwrap it in here, sort of asserting that the name of a symbol or a variable must not be empty. That's actually quite important. It must not be empty. So that's why we're unwrapping, so it crashes if it's empty, so that means there is somewhere a bug. Right, so and now I can just like take this thing in here, and there we go. Maybe I can even put expect in here. Expect. Empty names are not allowed. Right. There we go. So, and here we can finally replace this stuff like so. So this is going to be a name. Var or symbol from name, name text, like so. There we go. It's pretty cool. Now in here, var or sim from name, name txt. Var or name, var or sim, name text. Text. Let's give it a try. Is it gonna work? Is it gonna work now? Yo! So this thing, not found in the scope, so this thing has to be like self. Alright, var or, so it's located in here, and then self like so. Is it gonna work now? Please work. Oh, this one is interesting. So it has to be name to string, I suppose. Yeah. And it seems to be working, right? So, and another thing we should be able to do, by the way, is, for instance, use these, like use variables in the heads of the functors, right? If I capitalize pair, right? If I capitalize pair, pair has to become a variable. So now the head of the functor also became replaceable. Right, so this is what we have now. So everything is parsed appropriately, more or less. And let's actually go back into original thing. So I'm gonna just build this thing in here. I'm just gonna build this thing in here, and everything seems to be fine. So now we can test if this thing even works. Right. So I'm gonna define a rule. The rule is gonna be swap pair AB. I think I did a fucky-wacky and potentially oopsie-doopsie, so let's do a roll rep. Swap pair AB should be equal to pair BA, right? So here's the rule. So then I can do shaping. So I'm gonna shape swap pair, and what we're gonna do is f of x, g of y. And after that, if I apply the swap rule, it worked, but it shouldn't. It definitely... Oh, yeah, I see what's going on. It kind of worked, but what it did, it replaced the whole thing. But in reality, it shouldn't match. Right. it actually shouldn't match. So it didn't work as it worked before, but it didn't work correctly. So yeah, what it has to do, it has to like actually leave this expression as it is, right? It should have left it as it is. Why shouldn't it match? Because we don't have any variables in here. There is no a single variable in this rule, right? So it can only match that is literally equal to that. That's the only thing it can match. Otherwise, it can't match that. And I think I know why. So let's take a look at the pattern matching. So here's the pattern matching, and if we encounter... Oh, okay, so I never actually... God damn it. Okay. Okay. So this stuff only has to be like a variable, right? So only a variable has to be matched like this. If you encounter symbol, right, symbol name and another symbol name too should be equal. You can't really introduce any new bindings, but what you can do, you can just compare these two things, right? So if you have symbols with two names, that should work. If you have a variable, you just bind it like a variable to that sub-expression. If you have functions, you just do that. Cool. Okay, so, and yeah, we shouldn't actually match anything else. Alrighty. Okay, now I'm gonna try to do that one more time. I'm gonna copy paste this rule one more time. Okay, then I'm gonna start shaping this entire thing. As you can see, I'm shaping it, and then I'm gonna try to apply this swap. And as you can see, it didn't change, right? Because it didn't match. There is not a single variable in here that can match sub-expressions and do something with them. What should match, in fact, is a rule swap pair A, capital B equal pair capital B, capital A. That thing should match because here we have variables that actually bind to specific names. And if I apply this thing, as you can see, this expression got turned into that one. So we have a specific distinction between specific distinction between variables and symbols, if you know what I mean. So going back to our original issue, where we had confusion, right? So here I was trying to shape f of ABC, then I applied rule f equal g, and instead of getting g of ABC, I got just g, right? Because f was recognized as a variable and it matched the whole expression, and it just replaced the whole expression with g. So now, if I understand correctly, right, we can try shape f ABC, and here I'm going to try to apply a rule where f is equal to g. So the only sub-expression that it will match is the head of the functor, so it should successfully replace f with g. And that's precisely what you would expect in here, right? So the pattern matching went down and it hit the head, and the head matched exactly that rule, and it just replaced it with g. So now, as you can see, there is no confusion in here, and everything works correctly. So yeah, we introduced variables. What do you guys think? Isn't that cool? Isn't that cool? Well, I think it's pretty fucking cool. Does anyone have any questions about what we just done? So, by the way, now I think the add example is not going to work anymore, because as you can see here, we're matching actually symbols. So it is string matching. Would it match if G would use two arguments? It actually matched. So here's the thing. The head of a functor, this name, is also an expression, right? So let me update the syntax of the expression. So expression is either symbol or a functor or a variable. Let's put it this way, right? So because we introduced variables, the variable is something that starts with a capital letter, and then it has the same syntax as this thing. Right. So, and what's interesting is that symbol just simply does not necessarily start with capital letter, but it's something like this. Okay, and a functor head is just an expression, right? So because it can be either symbol or a variable or something else. Colon equals, I don't know, it's just like a definition for the BNF. I don't remember, like different people use different things in here. What if you have f of x? Would it replace both of them? I believe yes. f of x and apply a rule f equal g, and it replaces both of them, because right now apply applies all of the matches. Right. In the future, we're going to have different application strategies, right? So in the future, you'll be able to apply all, or apply the first match, or the second match, or maybe the first and fifth match, and so on and so forth. You'll be able to decide. And they're numbered based on the DFS traversal, right? So we have a DFS traversal, and how they're numbered as they encountered, so to speak. Right, so right now we just match all and replace all, but in the future we're gonna have like options how to match them and how to replace them. You're missing the second colon for var. Oh yeah, thank you. Okay. So what's interesting is that, okay, so we're done. I can replace both of the f's. But I can also replace, for instance, specifically only f of x, right? I can replace f of x with g of y. And as you can see, the inner one is replaced with g of y. Maybe a way to view matches then. Yeah, of course, when I'm gonna introducing the, like, numbering of specific matches, we're gonna have something that will visualize what is the first match, what is the second one, third one, and so on and so forth, so you can pick one. Maybe it's gonna be semi-interactive. Yeah, of course it's gonna be hard to, like, you know, count them. We're gonna have something to help the user to pick the specific match. Yeah. So what's interesting is that apply right now finds the first match, replaces, and backtracks. So if the replacement creates an expression that matches again, it will not actually go like deeper. So we might have another strategy that replaces and goes down into the replaced expression, hoping to find something to match again, so it can go like deeper and deeper and deeper. So there's a lot of room for different strategies of rule matching and rule application. You know what I mean? Right, so yeah, and we're gonna try to be as flexible as possible. The user will decide how exactly they want to match things. So it's gonna be interesting, I think. Right now there's only one strategy. So yeah, let me maybe quit, and I want to just test how the piano numbers work. Can you currently have infinite recursion? You can have infinite recursion. But because of the nature of rule substitution, you basically have to press enter every time you go into recursive call. Right, so let's actually take a look at that. So can we define a rule that is recursively grows all the time? Right, so let's assume that we're gonna have a rule, inc, whatever, just a random name. F of x is going to be equal to f of x, regardless of what x is equal to. Right, so here's the rule. I'm gonna now shape f of 69, right, and I'm gonna apply inc, and I'm gonna apply inc again. And as you can see, I have to just do that manually. But again, in the future, we're gonna have a strategy that applies the rule until it's applicable. So when you will use that strategy that we'll implement later, maybe you will get a situation when you have infinite loop. So yeah, here's the thing, my computer is really lagging right now, so I really apologize for that. So I'm gonna turn off the music. So I think this is because of the music, but it's not supposed to be like that. Okay. Not lagging. Okay, so should have not actually turned off the music. But... So, do you guys miss the music? Because I turned off the music. So I have a bell in here. It's not actually a bell. It's a lamp. But it sounds like a bell. I really like that. Anyway, so you have this kind of stuff. Yep. Isn't that cool? We can also apply a rule where f of x should be replaced with g of x. Right. Ooh, that's interesting. Huh. That's pretty cool. And what if we do something like g double g should be replaced with q? It can be replaced even further, but yeah, you can do different things like that. But anyway, what I was thinking about checking my piano numbers example, right? So here's the piano numbers, and it's not gonna work anymore. So if I try to execute the piano numbers, right? People really enjoyed me singing in my old videos. Yeah, I used to do that. So as you can see, piano numbers don't work anymore, right? Because we're not using like a proper variables. What we have to do in here is convert things into variables. And after that, everything should work properly. Hopefully, we'll see. There we go. And as you can see, here is the sum, right? So the sum is working properly. So another thing I had in here is the swap example. It's actually a very dumb example. It doesn't do anything interesting, right? But it also needs to be updated at some point. So here we have variables, right? So here are the variables, and here we have variables as well. And now, if I try to do swap, did it work? I don't think so. I think I should have done something like this, right? Yeah, now it worked. So first we swapped two things, then we constructed triple out of pair and we rotated it, and there we go, this is what we have. So there's another interesting example called derivative, and this is something I was talking about at the, I think, second stream or third stream, I don't quite remember, but this was the original sort of like draft of what language I want. Right, so I was doodling around with derivatives, and I wanted to have like an automated way to prove that the derivative of square of a square is actually 2x. Right, you see what I'm talking about? I wanted to like sort of quickly demonstrate that derivative of x to the power of 2 is actually equal to 2x, right? And I wanted to do that by defining like a bunch of rules, right, and then sequentially applying them, right? So, and this is what I came up with at some point. So this does not work yet because we don't have binary operators. So in the future, on top of having functors, we're also going to have binary operators, right? And you'll be able to match them as their functors or something like that. And yeah, so my ultimate goal is to make this example work and demonstrate that the derivative of square root, why I keep saying square root, I'm sorry, of x squared. I'm already tired. So the derivative of x squared is 2x, right? So that was the thing, but it doesn't work anyway, right? But I'm slowly moving there, okay, good. All right, so I think we're done with variables, right? And I'm ready to do a committee and potentially a pushy. So let me see if I need to update anything in here. So yeah, so here's expressions. So I probably need to update this kind of stuff, right? So maybe I also need to mention the differences between symbols and variables at some point, but maybe a little bit later. Okay. Introduce variables. and then we're gonna close issue number 1. I'm gonna push that right into the repo. There we go. So the first issue is done. How about that? Okay. So that was the topic for today, but I still have a little bit of time left, and I was thinking, what could I implement? So another thing that I wanted to implement is an ability to roll back, if you know what I mean. Right, it's kind of cool that you can, you know, apply the rules and stuff like that, but at some point you may mess up. You know what I mean? You may mess up, and because of that you want to be able to just like undo something. What I was thinking is that maybe we can introduce a keyword for undo, right? So literally, so you're applying the rules, and at some point, I didn't want to apply that rule, I'm going to put undo in here, right? It's not going to be useful for the source code, right? Because in the source code it's supposed to work, but it could be useful in the repo, right? So you're just applying the thing and you're just realizing, nah, this is not what I wanted to do. I want to undo that thing. So reverse, inverse the operation, yeah. I'm thinking actually, can you swap head and body of the rule and apply that rule again? Will that work? Will that always work? Maybe. That's very interesting, actually. Never thought about that. No. It could be one way. But here's the thing. So if I will do something like, I have an idea. What if every time I apply a rule, right? Every time I apply a rule, I push that rule to a history of applied rule, right? It's going to be a history of applied rule. And then when I do undo, I just pop the rule from the history, swap its head and body, and apply it again. If some rules, I can't understand you, symbols in the head, it won't work. I think it will work. I think it will, because we have a distinction between symbols and variables. That's the thing. We have a distinction between symbols and variables, so it might work. Though instead we can just have a history of expressions, right? So we can just like have a vector of expressions, and every time we pop, we just replace it back. Yeah, I think it would be easier to just like push the whole thing. Yeah, let's just push the whole thing. By the way, do you guys miss music? I can bring the music back, because I'm not sure if it was like actually logging. All right. All right, so let's go ahead and just introduce something. So I'm going to introduce a new keyword. It's going to be in Alexa. Where are the keywords? So here is the quit, and we're going to have undo. So here is undo. And we also have this thing, right? So if I do undo, it has to be undo keyword. And let me try to build this thing one more time. So if the stream starts lagging yet again, please let me know. Oh, by the way, right, here's the thing. I wanted an ability to know the amount of elements of enumeration, but I didn't want to bring in a third-party dependency. You know, it's just like, it's a very simple thing. It's like a fundamental thing that you should have in a language. And in Rust, it's a third-party dependency. So what I did, I implemented that dependency myself, right? Essentially, I have a special macro that defines enumeration, right? And then it also defines an array of all of the elements of that enumeration, so I know the amount of things and I can iterate them and stuff like that. So this is what basically I did. And that way I don't depend on any third-party dependency, right? Because I think for such a simple thing, you should not have a third-party dependency. It should be built into the language, in my opinion. Otherwise, you just like create an NPM disaster. Right. Okay. So we have undo, and what else do we have in here? So yeah, done, undo, undo. Is that it? If I try to do undo right now, I think it will fail. Yeah, so one of the things we have to do now, we have to go to main. And if I remember correctly, it was called process command. Okay, so here we can say that now we also expect undo. So this is one of the tokens that we expect in here. And when we get undo, what do we do when we get undo? That's a good question. What do we do when we get undo? So we need to have implement undo command. I think we should have a history of those things, right? Let me see. Shaping history. So this is a shaping history, and this is literally a vector of those things. Every time I successfully apply something, right? Every time I successfully apply something. So this is apply all. Okay, so there is at least 2 times I apply something. So I have new expression 2 times. What I need to do is probably push the old expression into... yeah, I think I need to push it into history. So it's going to be self, history, shaping history. Stream is lagging again. Okay, so I think it is lagging because of the music. I'll have to actually... the computer also lagging for me too. So, yeah. Can I just push this expression here? I think I should be able to. Okay. And in here, let me see. So effectively, I'm moving expression into the vector. Hopefully, I'm moving it there. And then I'm going to be reassigning it. Hopefully that will work. I hope Rust is smart enough to actually recognize what I'm trying to do. Right, expected enum, but found this thing. And in here, I wonder if it is actually smart enough to let me do it. No, it was not smart enough, unfortunately. God damn it. Okay, so I think option has a way to move its current element out of the option, replacing it with a new one and allowing you to, I think it's literally insert, isn't it? So let me actually see. Does anyone know this operation that allows you to replace option and move thing out? So get or insert. Replace. Yeah, that's what I'm talking about. Replace the actual value in the option by the value given in the parameter. Yeah, so that's basically what I'm talking about. And I wonder if I can use that. That's the good question. So because of that, I can take current expression, take. Okay, so let me take a look at take. I think I need replace. I think I actually need replace. So I'm gonna do new expression. All right. And what's funny is that current expression must have something. It must have something, and it's guaranteed to have something, so I can unwrap this entire thing. And unfortunately, this is already borrowed. That's the problem here. This thing is already borrowed, but at the same time, it was okay with me assigning it, so it should be fine. So self shaping history, history, and I'm gonna push this thing that was moved out. Yeah, so that's the cool thing here. Like I'm replacing it, moving it out, and moving it into the vector. So I think this should be fine, hopefully. Interestingly enough, so that means here I'll have to do that before I actually moved it into that thing. Almost. So because of that I have to do it like this. Hey Lee, brother! Okay, cool. That's actually pretty cool. So I'm not copying anything in here, right? So whatever expression I had in the current expression, I don't copy it, I just move it into the history, right? So there's no copying, there's only movement. And the new expression that is constructed, it's also moved into the option. That's pretty cool. Okay. Rather than unwrap, why not just do an if let? You see, if this thing returns none, that means the invariant that is set by this condition is actually violated. So I want to assert the fact that current expression always has a value at this particular point. So to assert that, I'm unwrapping it. Might as well actually use expect. Expect current expr must have something. So here's another interesting thing. When we're done, I also need to clean the shaping history. I also need to clear. I think it's clear. Though it would be nice if it was possible to like actually guarantee that on the type level that this thing has something. I wonder if I can make it mutable. Nah, probably not. I think it's too complicated. I think just asserting it is fine for now. Even though I think it should be possible to not do that. Okay, seems fine. What I was doing, by the way? I remember. Anyway, so yeah, undo doesn't work. Right, because we haven't implemented it yet. So how we're going to be implementing it? What's important is that we should have something. We should be in a shaping mode, right? We must be in a shaping mode when we are doing all of that, right? If we're not in a shaping mode, we have to return error, no shaping in place. So there is no shaping in place, and we have to use keyword location to indicate the location of where that happened. Okay, so after that, I should be able to pop an element out of the thing. So let me take a look at the pop. So here's the vector pop, and I suppose pop returns, it moves the element out of the vector, right? So I'm pretty sure it does. I really apologize for my slow laptop, and this is because it's 10 years old and I'm also streaming on it. And also I don't have an opportunity to buy a new one because I live in Russia. Why I keep reminding myself that I live in Russia? I should stop doing that because I get depressed every time I remember what's the country I live in. So I'm really sorry. Okay. So what we need to do in here, self, what's going to happen when we reached the end of the history? We should probably throw a special error. You know what I'm talking about? Like some sort of special error. Right, so shaping history, pop, right. If let some previous expression, laptop with Baikal processor to rescue. Baikal processor? You mean Elbrus? Is there such thing as Baikal processor? I think it was Elbrus. But doesn't really matter. They're not manufactured in Russia anyway, so doesn't matter. So, and we have a previous one. What I need to do is self current expression replace with the previous, so I'm essentially moving it back. Otherwise, I return error no history. That's one of the things we can do, right? So there's a no history in here. Okay, so either you don't have a shaping in place or you reach the end of the history, so that should be fine. Wasn't Baikal from USSR and Elbrus from today's Russia? I don't really know, honestly. Does it really matter at this point? Okay, no history. All right. Found an option. So expected nothing but found an option. I don't know what is going on. So yeah, this one is rather interesting. So probably need to put a semicolon here. Okay, so now we have these situations where we have to process them. So here we are processing the file, right? So this is the file. No history. So println. So here's the location error. No history. Right, and here is the location of this thing. There we go. So in REPL, it has to be slightly different. Right, error, no history. I think it's just location, and we have to print the location cursor. The location cursor is a really interesting thing. It just like points at the token where you fucked up. So I'm gonna show you soon. So I'm going to no history. So let me see if it works or not. So we have two separate modes of error reporting. The first one for files, when you interpret files, and the second one for REPL. And depending on these modes, you just report errors slightly differently. But they're the same errors anyway. So if you define a rule, right, and you, I don't know, just put some stuff like that, you forgot to define a name, right? It will tell you expected symbol but got open parent, right? And it points exactly at the token that it's not happy with, right? So this is basically the cursor, right? The position cursor. That's why I needed to print it, because it calculates the position and puts it there. All right, so if I try to do undo, no shaping in place, and it also points at the token saying that there's no shaping in place. Okay, so let's try to copy paste a bunch of things from examples, right? So we're gonna have add, and I'm gonna just copy paste this thing in here. We do support comments even in the REPL as well, because we're using the same tokenizer, so that should be fine. Right, so this is the second thing, and we're gonna start the shaping. All right, so I can apply add a couple of times. Right, so apply add, and now I can try to undo. And that's very bad thing, because what I forgot is I forgot to print the expression after I undid it. Is that even a word? By the way, since do is a regular verb, is undo also an irregular verb? Think about that. Can you undid, undone? I think it's also because it's derived from a regular verb, so it has to be a regular verb as well. Otherwise, you have to say undo it, and doesn't. And did it. Okay. All right. So thank you everyone. So yeah, what was that? I forgot. Yeah, I want you to print the expression that I just undid. Right. So I just replaced it. Right. And before I have to do something like print ln space equal. And then I can take the previous expression and I can just put it like that. Right. So I have to put it by a reference, because I move it out of the history, and if I try to print like that, I will move it into printing, so I won't be able to move it in here, I think. I haven't tested it yet, but that's the hypothesis. Okay, so it seems fine, and now let's try to do that. I think there should be also some sort of visual indication that a particular rule is defined, because it's kind of silent, right? You define the rule, nothing happened. It's kind of weird, but I don't know. Maybe that's fine. Maybe that's fine. So because especially in Python, if you define a particular function, right? If you define f of x return x, what's gonna happen? It's not gonna print anything. Well, it kind of did, so there was some sort of indication, but I'm not sure how intentional it was. But anyway, so here's the shaping. We can apply add a couple of times, right? So we're applying add. Now I want to undo this thing, so we should go back into the previous expression, and we should go back yet again. So we're back at where we were, and then if I try to do undo, it will say no history, but I can try to apply add one more time, because there is a shaping in place, and at some point I can do done, and it's fine. I can do undo, no shaping in place. So far so good. You can undo things, so we keep track of the history. Yeah. Another thing I would try to do, so you can use undo in source code automatically, right? Because we use the same engine to interpret REPL and files, but in source code it's not that useful, I think, right? It's more of an interactive thing, but we're gonna support it anyway, because why not? Why not? Maybe in the future it's gonna be useful for conditional application of rules. Maybe there will be some sort of conditional application of rules, and at some point, if condition is met, you would be able to say undo previous rule and do another one. So maybe for this kind of stuff it's going to be useful. I don't know yet. So there's no reason to not allow that in source code files. So, and let's actually add that to the editor support, right? So since it's a legit keyword, why not just add it to the editor? So the user can see that it's a special command that does things. All right, so, and let me go to this stuff. I'm going to copy paste this stuff in here, and yeah. Like that. If conditional application of rules wouldn't need anything like add 0, I don't know how conditional application of rules will look like, and I'm not even sure if we'll even have one. I just like it's a hypothesis, right? So maybe something like that would be useful, but I don't even know how it's gonna look like. Do we even need that? Maybe not. I don't know. So it's just like, you know, whatever. Okay, so if I try to open some of the examples, right, will it highlight undo? It does highlight undo, right? So we can just undo that or do it again. So there we go. Okay, good. So I'm already streaming for 2 hours, so that means that's it for today. Does anyone have any questions about this beautiful, beautiful language that we're developing? You can find the source code of this language in here, in the chat, or if you're watching on YouTube, you can find it in the description. Let me know what you think about that language. Do you have any questions? Is the goal of the language clear? I think after I demonstrated a couple of examples, it became more clear. So now we have like concrete things you can do with this kind of stuff, which is cool. I'm actually super happy. No content for YouTube for 3 weeks. Yeah, I'm really sorry. I was completely demoralized because of the war. So I kind of took a break. I'm really sorry about that. So I'm trying to slowly get into the rhythm of making content again, even though I'm not getting paid for that, but I'm still want to make the content because I enjoy that. So give me some time. So I just like do streams, and soon I'll have motivation to start uploading to YouTube again. I use Wolfram Alpha for this, but it's inconvenient. Yeah, I suppose. The things like Wolfram Alpha or Coq, at least the problem that I have with this mathematical system is that they're very, I don't know, you have little control of how the expressions are transformed. quite often when I'm transforming expressions, I want to have like very precise control over how I transform one thing into another one. And that's what I'm trying to do in here. Do you have any plans to apply Noq experience to Porth in some way? Probably not. Noq and Porth are completely separate projects. It's just like Noq is something that I had at the back of my head for quite some time. And it's not as ambitious of a project as Porth. So I decided that I'm going to just quickly implement that project and move on with something else. I think that syntax is hard to understand. It's not final, as usual. Syntax is never final. You can always change it. Are you done with Porth now? Of course not. Of course not. It's not even close to being done. This expression transforming thing kind of sounds like optimization. I guess. Maybe. Optimization of what? What do I mean by optimization? Optimization of industrial processes or what? Optimization is a very broad and general thing. What do you mean by optimization? Did you know that Google text-to-speech cannot pronounce gvozd? I'm not going to check that on the stream. I'm going to check that off screen. I'm an experienced streamer. I'm not going to be checking that on stream. Okay. Constant folding. Maybe constant folding, yeah, why not? But isn't... how common it is to do constant folding on a level of AST? Because you can do like constant folding on different levels. You can translate it to intermediate representation into some sort of virtual machine and do constant folding there by evaluating some of the instructions or something like that. I don't know. I never implemented constant folding. I know what it is, but I never implemented one, so I'm not really sure at which level I would personally do that. If I were to implement constant folding for Porth, I would do that on a level of intermediate representation, but this is purely because Porth doesn't have AST, and intermediate representation is basically AST of Porth. So, but if I were implementing like a more conventional language, I don't know. I don't know. Constant folding can happen on both AST and IR levels. Oh, okay. So in that case, it is like constant folding on the AST level, but this is a very specific optimization implemented in a very specific way. Constant folding, it's a very narrow and specific thing. So, but I guess I do agree. It does look like constant folding, but it's not necessarily folding expressions because it can unfold them as well, right? So it does not reduce them necessarily, because one of the things we did, right, we tried to shape the following thing. We tried to shape f of x, and we applied the rule where f of x, right, is equal to f of x, right? And you keep applying it, and expression grows and grows and grows and grows. So there is no folding in here, right? It's not necessarily folding. It can be an infinite unfolding, right? You see what I mean? So yeah, but there are similarities between like constant folding and what we have in here. What about removing multiple swaps? I'm not sure what you mean. Would that increase performance much, or is that not really an issue? What do you mean by multiple swaps? Do you mean swap as the rule we defined in a very specific example in here? Swap is not an integral part of the language. It's just one of the rules that I use as an example to demonstrate what the language is capable of, right? It's not a built-in capability of language, right? So I'm not sure what you mean, I'm sorry. All right. This recursive rule looks similar to constructing infinite list field with a single value. Yeah, I guess. So you can even do something like shape f of 0, right? And can I apply a rule f of I don't know, x equal f x. And you can do stuff like that, I suppose. It's a pretty cool system, actually. And surprisingly, it's a very small system. Do I have to do dot? I think I have to do dot. Look, it's not even 1,000 lines of Rust. And it doesn't use any third-party dependencies, yes. Right, so it's like a pure Rust without any dependencies, and it's just like not even 1,000 lines of code. Right, it's a very simple system, and it's a very interesting one. All right, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all. And next time, I don't know what we're gonna do next time. Maybe we're gonna continue doing Porth, or maybe if I find more interesting stuff to do with Noq, we can work on Noq again. And yeah, should we raid somebody? I don't know, we haven't raided anyone for quite some time, primarily because I wasn't streaming for quite some time, so let me see. Let me see, yo. So unfortunately Twitch is very slow, so do you guys have any suggestions on who to raid today? Hero Dev, I don't know who that is. Raid Hero Dev. Oh, it's only one person saying that. Oh, I'm even following them. Who's that Hero Dev? Okay, so what are they doing? C compiler for GPU. Okay, sounds fun. Different apply strategies for Noq next time. Maybe, we'll see. So I need to explore that first. So raid hero. I think I recognize the profile pic, but unfortunately I don't remember what was his previous nickname, so I don't even know. Will you upload recent streams to YouTube? I'll try. I'll do my honest attempt at doing that, but I can't promise anything. All right. Come on, Twitch, you can do that. Okay, it showed the thing. It didn't show the text yet because showing text is actually hard. So yeah. So yeah, get ready for the raid, boys and girls. Get ready for the raid, and I see you all next time. Love you all.